Hello, my name is Archie, and I will be explaining to you how to solve a problem about the application of vectors. Vectors are used in our daily lives, and it is critical to know how they work, from knowing how fast a car is moving to calculating the speed of the wind affecting a plane in the air. We see vectors everywhere, all the time. The problem we will be solving today is about a plane in the air. It is flying at a ground speed of 330 km per hour south 30 degrees east when it encounters a wind that is moving at a speed of 60 km per hour from south 5 degrees west. We need to find the speed of the plane relative to the air in kilometers per hour, the direction at which the pilot should head the plane to reach the destination. We also need to have a detailed vector diagram to help us out. Firstly, let's make our vector diagram. So, we're going to have our north, east, south, and west. We can draw out a vector at south 30 degrees east, which is our plane's velocity relative to the ground. Label it 330. We will call it VPG. Now, before we draw our vector for the wind, we need to keep in mind that since the problem says the wind is coming from south 5 degrees west, it means the wind is going in the opposite direction. Opposite of south 5 degrees west is north 5 degrees east. So, we can draw a vector at north 5 degrees east and label it 60. We will call it VHE. We can draw a dotted line to show the plane's velocity in the air. We will call it VPA. Knowing that the inside angle of VHE is 90 degrees minus 5 degrees, which equals 85, and the inside angle of VPG is 90 degrees minus 30 degrees, which equals 60 degrees, we can add them up to find the angle where the two vectors intersect, which would be 60 degrees plus 85 degrees, which equals to 145 degrees. Now, we can find the plane's velocity relative to the air. We can use cosine law to find the length of VPA, the plane's velocity in the air. Cosine law is c equals square root side a squared plus side b squared minus 2 times side a times side b times cos angle. Our side a is 330, side b is 60, and the angle is 145 degrees. Doing this, we can get VPA to equal square root of 330 squared plus 60 squared minus 2 times 330 times 60 times cos 145 degrees, which equals to 380.70 kilometers per hour. Therefore, the plane's velocity relative to the air is 380.70 kilometers per hour. Now that we have this, we can find the angle at which the plane needs to head. To do this, I like to use sine law since we have one angle and three sides. Sine law is sine alpha over side A, which equals to sine beta over side B. Our alpha is 145 degrees, beta is the red arrow, side A is VPA, which is 380.70, and side B is VPG, which is 330. So we can set up our equation to be sine 145 degrees divided by 380.70 equals sine beta over 330. So our answer for our angle would be 29.81 degrees. Finding the final answer, it would be 180 minus 29.81 minus the inside angle of VHE, which is 85, giving us 65.19. Therefore, the pilot needs to direct the plane to fly at east 65.19 degrees south. Another way to solve this problem is to find the other angle and then add the outer angle of the vector VPG, which is 60 degrees, to it. Our alpha would still be 145 degrees, and beta would be the new angle being shown by the red arrow. Side A would stay as VPA, which is 380.70, while side B becomes VHE, which is 60. Using sine law again, it would be sine 145 degrees divided by 380.70 equals sine beta over 60, which equals to 5.19 degrees. Adding the outside angle of VPG, 60 degrees, gives us 65.19 degrees again. Therefore, the pilot needs to direct the plane to fly east 65.19 degrees south. In conclusion, the plane's velocity relative to the air is 380.70 kilometers per hour, and the pilot needs to head the plane east 65.19 degrees south to reach their destination. Thank you for watching. I hope you enjoyed the video.